Hello everyone, welcome to the Innovator Coffee, a podcast that bridges the gap between people and the world of AI and innovation. We're Tom and Wickey. Follow us to explore the top AI applications, ecosystem insights, and the emerging trends. Today, we're honored to have Lu, Fusion Fund founding partner, Ben, co-founder of Kscale, a hot robotic startup, and Yutong, our guest host, to share their points of view on AI robotics and entrepreneurships.
Very welcome to the speaker to our podcast. It's Zhang Lu from Fusion Fund, and maybe you can introduce a little bit about your background.
Yeah, happy to. Thank you, Chang. Thank you for having me for the podcast. I'm Lu. I'm the founder and managing partner of Fusion Fund. We're a Silicon Valley-based VC firm, mainly focused on early-stage startup investing. The three verticals we've been focusing on in the past couple of years, including healthcare, mainly AI in healthcare, enterprise AI, do both vertical AI and also horizontal AI infrastructure. And the last vertical is industry automation, how to apply AI technology to the traditional logistic automation and also space industry. Before I started Fusion in 2015, I was an entrepreneur. I built and sold my own company before so-called went to the dark side and started Fusion Fund. Since 2015, we've been supporting and also investing early stage startup companies and focus on Series A stage. And now we have over 92 portfolio companies across the United States.
Thank you. Hi, welcome also Ben. We know that you run a startup company and you work for Tesla or Robotics before. Could you introduce a little bit about your background also?
Yeah, I'm Ben. I'm the founder and CEO of Kscale Labs. I started Kscale in January. We finished the YC Winter 24 batch. Before that, I was an AI researcher at Facebook AI on the robotics research team in New York. Before that, I was, as you said, an AI researcher, engineer at Tesla on the autopilot team. Deployed some of the first models, end-to-end, like transformer models to run on the Tesla ASIC. And then before that, I was also at Facebook AI working on representation learning for speech. So yeah, been in AI research for a long time.
Fantastic. Ben, tell us more about your startup. We know you're working in Tesla and Meta, mainly helping on the large language model, right? And how did the past experience bring you to the current path?
Yeah, I started Kscale because I saw that there was a lot of humanoid robot companies getting started in the United States that were targeting sort of a $20K USD price point. And I felt that this was unlikely to be the price point so in order to have a humanoid robot be useful, I think that the price needs to be closer to somewhere like 2 to 3K, about the price of Apple Vision Pro, because the first robots are not going to be able to do very much. Like, it's the same way that the early language models were not able to do very much. So decided to build one during YC that we could 3D print. We were just buying actuators from a manufacturer in China. Our bill of materials was around 8K. We figured if we could build it in a garage with two guys, there was not a lot of IP, so we decided to open source it. What we're actually building is essentially a platform for enthusiasts and hobbyists to get started programming humanoid robots very easily. I worked in robotics at Facebook, and the bane of my existence was we would get a robot and it would take a week to set it up and work out all of the bugs. Whereas if you could just buy a robot and it would come preloaded with all of the software to interact with the cameras, the motors, and you can just program it using some type of high-level description language, then it would be something that a lot more people would want to try out. And I think the lesson of AI has been that if you want to actually have a good AI model, you need to have something that people can easily try out for a low-risk, sort of low-cost application, and use the sort of experience and data that you get from people using it to improve the underlying model. So that's what I'm trying to do. The right first customer for humanoid robots will be the same first customer as people that bought personal computers early on. It'll be the same type of person that bought like VR headsets, sort of like phones. They're not exactly just consumers. They're kind of like tech tech literate people that are willing to kind of work around the edges of a product that's not perfect yet to kind of make it good. It's meaningfully different from someone that bought a Tesla, the first Teslas. The people that bought the first Teslas, they were expecting something great. If you put $200K onto a car payment, you expect it to be a really good car, like it's very like sexy kind of feeling to drive it, like all of the stuff that Elon Musk is good at. But it won't be the case for humanoid robots. Like even if you bought a $200,000 humanoid robot, it's just not going to be useful for like a while, probably for 5 years. So if you want to actually get something out and find like PMF, it's going to have to be people that are enthusiasts, hobbyists. It has to be at a price point that they can afford. And it has to be done in a way that you can actually leverage the fact that those people want to build a good robot to kind of like, make the next version better. Yeah.
So you're saying it's more like a motorcycle type of fun way, and they try to explore more to help finish whatever they want to have.
Yeah.
Something like that.
Well, I should say, I guess the real answer is that I'm the target customer. So when I was at Facebook last year, I really wanted to buy a humanoid robot. I sent emails to 1X and I was like, can I buy one? Even 70K, I'll have to talk to my wife, but I think we could probably. I had money from working at Facebook. I would buy it before it's good. I know that they're not good right now. So, and essentially, and I even wanted to buy one from Unitree, but that it was only available for 90K. I looked around a lot to buy them, and so essentially, Kscale is my mission to basically build something for myself. Because even if the company goes bankrupt, at least I'll have one that I built from me. And I think there's enough people like me to justify kind of an early product, product roadmap. And I know what people like me want, because I think that basically the right first customer, at least the customer we're building for at Kscale, is someone like me, like robotics fluent, like programmer, willing to work around the edges because they want a cool thing. Yeah.
Sounds like your customer profile is like an Apple fan or something, right?
Yeah, I mean, the people responded, so we really tried to build something. We did the open source avenue because we wanted to get something out there that people could see and just see who wants it. If you really want to kind of maximally get people on board with this mission, it has to be this kind of shared sense that we're building a robot together. The whole world is kind of participating in this project of building, a really useful embodied AI agent. That's what's motivating for me.
Why do you think that we need to build a humanoid robot instead of just a robot arm? Because I see that robots are being used in e-commerce, but it doesn't have to be humanoid robot. And I heard that having 5 fingers is way harder to manipulate than having just 2 contact points. So what do you think?
Well, my personal opinion is that we don't necessarily need to build a humanoid robot. I think it's mainly, it'll just be if you want to build software for embodied AI, it'll have to be used to control a humanoid because of just the dynamics of what's happening in the world. Specifically, there's a lot of companies in China that want to build humanoid robots. And so there's going to be cheap humanoid robots soon, if not already. AGI Bot just announced a $5,000 humanoid robot. Unitree has their $16,000 one, and we've have manufacturing partners for the 10K range. I think it's kind of the reason why we've been able to find people that want to work with us is because there's a lot of energy to produce humanoid robots specifically. Not just robots on wheels, and I think there's a pretty good argument that humanoids are the right form factor for embodied AI, or one of the right form factors. The classic thing is that a lot of human spaces are built for humanoids. So if you want to have a humanoid that can operate reliably in every different context that a human operates in, it should look like a human. I think aesthetically humanoids are a good form factor. If you want to have something that really people can feel comfortable around, I think it's better to have a humanoid than a spider bot. One thing we've tried to do really is make ours look kind of cute so that people are actually interested in interacting with it.
So, Lou, what's your opinion on this question?
Because many people ask me that questions as well. To be honest, we're not like only looking at humanoid robotics. So, to be honest, for the sector we're focusing on, that's not necessarily the best, the most cost-efficient option as well. I think we have to think about what is the use cases for different type of robotics. I do agree with, I think it's Ben, right, mentioned that I heard this a lot, saying that the world is created by human for human. So if we have human-shaped robotics, it will easily to integrate with existing. For example, you could now climb on the stairs with the rail, but if you are human-like, you could have the leg and climb the stairs. So that's more like consumer-facing, consumer interact. But if it's for specific industry application, we're talking about the supply chain, our inventory management. The whole factory could have 100% robotics, no human. And also the factory might be built from scratch, specific design for robotics arm to integrate, might be cheaper and also might be easier to integrate use non-human shaped robotics. So that's the reason for the sector we're looking at, healthcare industry, healthcare traditional sector, manufacturing space industry. That's not necessarily the best option. And another probably not very accurate analogy I want to share for everyone to think about for self-driving. We could have two options or two different phases. The phase one is you have self-driving car like Tesla driving together with lots of the human drivers still on the road. So for a model, it's very important to learn how human drive the car and also the craziness human can go in order to adapt to self-driving behavior. But if one day we only have self-driving car on the street, the robotics of the car itself does not necessarily need to learn the crazy edge cases potential causing by human. So that's kind of two scenarios. Come back to the robotics questions. Are we going to have robotics mixed with human labor, adapt to the existing infrastructure as a final option, or one day we'll probably have a new infrastructure build up a specific design for human labors? And also whether human labor going to be a service implemented with all different industries. We don't have the answer yet. That's the reason I think both directions have lots of innovation we should explore, but I never think should be one or another.
From your opinion, what's the best use cases for the robotics?
So historically, robots are good for things that are repetitive. I think the acronym is, or the phrase is dull, dirty, dangerous. So things that are repetitive and boring, things that are, involve going into hazardous situations, or just things that humans don't want to do.
Like an earthquake rescue or something.
Earthquake rescue. There's an example that I was talking to a potential customer about where it's kind of welding inside shipyards, where you go down into the bottom of a ship and then the argon gas from the welding torch accumulates and then you can drown in it, where it would be nice to have a robot do that kind of thing. I think that's like historically what robots are good for. I think moving forward, the reason people will use robots will actually look a lot more like the reason people use existing AI technologies. So, for example, the question is, why do people use ChatGPT even? It's not because ChatGPT is necessarily good at like automating repetitive tasks, although that is certainly something people use it for. I think it's more like people use these large language models and emerging AI tools for kind of random things. That was just what I'd heard from someone that works at OpenAI. So I think the same thing will be true for robots moving forward, where people will use robots for things like friendship and companionship. I think people will use them for like assisting with things that you don't think of as like well-defined tasks, but if you had an extra pair of hands, you would want to have it there. The example that I personally want to use a robot for is like my wife leaves cans of like soda around the house after she drinks them and she puts them down and then forgets them. And I would just, it'd be nice if like a robot could go and just pick them up. But that's a very poorly defined category of services. It's not like, it's not exactly a maid. It's not exactly like, a cleaning robot. It's like a robot to do this one thing. And if you can have a single platform that can do lots and lots of these sort of weird small things, it'll be worth people's time to buy it. I suspect that the place where humanoid robots will have PMF at first will be enthusiasts and hobbyists. I've just done enough talks with different potential, B2B customers that I just don't imagine us building a useful product for them anytime soon. I don't imagine anyone building a useful product for them.
Which robot in the industry do you like the most?
I like different robots for different reasons. I really like the Fourier intelligence one. Our first robot was basically designed similarly to the Fourier intelligence one because it looks really cool. Their movement's pretty natural. It does not do very well with sim to real transfer though. Like we had a really hard time actually simulating that robot. And then I've also heard people that have developed on it, they have a hard time with sim to real transfer. So, now my opinion is more or less that whatever robot is the cheapest is the one that I like the most.
That makes sense.
There's a few design principles that I think are important to follow. I think the Tesla bot, at least the version I've seen most recently, is not very good at following those design principles. I think the Chinese robots are almost all better as a sort of broad category of Chinese robots as opposed to Tesla and Figure. But again, not an expert on manufacturing, only expert on kind of building, open source humanoids, and this has been my observation. I've toured some of the factories too, so yeah.
Yeah.
May I ask who are your kind of main competitors, if you want to mention? Do you have someone kind of you quite admire, or you think they're doing quite good? Or?
The person I admire the most is Wang Xingxing at Unitree.
Unitree.
He's incredible. I got to meet him in Hangzhou like a month ago. He doesn't really speak English, and my Chinese is not very good, so I had to have a translator. But he's just so good. He's like such a good engineer. Mm-hmm. It's very incredible to talk to him. And I think it's obvious if you look at Unitree product, it's very good. Yeah, I really like Unitree. I think Unitree is going to be like one of the biggest winners.
Making robots move flexible and effective in complex, unstructured environment is one of the most important topics in the robotic research. How do you plan to address the issue in your actual entrepreneur efforts, and how to evaluate whether you are doing well?
Yeah, so I think that the really interesting thing about like why there's a lot of humanoid robot companies now, if you kind of look at the hardware that they're using, it's a specific type of hardware. Like everyone is using a quasi-direct drive BLDCs, brushless DC motors, and the quasi-direct drive meaning that they're all using planetary gearboxes with like somewhere between a 6-to-1 and a 30-to-1 reduction ratio. So they're low, like pretty low inertia, relatively high torque gearboxes, which is different from like previous robotics approaches. Like you're not using like lead screws, so it's all the joints are back drivable. They're all compliant. It's like getting the balance of like high torque and compliance right. There's a lot of there's even deeper nuances in actually making these things reliable. Like the original MIT Cheetah actuator that everyone's kind of basing this on was had a weird number of teeth, and if you ran it a long enough time, the teeth would wear down in a weird pattern. So a lot of the companies that have changed the number of teeth. So there's like stuff like that is like, I think, on the hardware side is what people are doing to make them compliant. But yeah, like most of the robots are able to do sort of human level movements because they're just using BLDCs, like quasi-direct drive BLDCs. That's a big innovation. Oh, and I should also say the reason why that innovation was possible in the first place was because this guy Ben Katz at MIT decided to release his motor controller and motor design open source. So in a weird way, an open source project basically catalyzed the entire humanoid robot industry. And yeah, I think we're sort of it's exciting to think about there's an opportunity to have this sort of open source ethos sort of industry wide. Even AGI bot, their latest robot is going to be open source too.
What do you think are the biggest challenge in terms of both hardware and software?
Well, I think robots are fun because it's basically a combination of all of the hard problems in both robotics and machine learning. I think that right now is a good time to build humanoid robots because you're starting to see the emergence of, large, learned methods for robotic control, which makes it easier to make robots do useful things than, trying to hand code everything yourself, which is exciting. But getting those methods to work well is still a hard challenge. So, there's two very popular robots in academia, one from Fourier Intelligence and one from Unitree. And the one from Fourier is kind of notoriously hard to use for these kind of like learned methods. Whereas the Unitree one is become more popular because you can do much better like sim to real transfer. And the reason that's the case, there's a whole litany of technical reasons down to the level of the motor controller. But essentially, I think a big part of it is that Unitree open sourced their URDF, like the simulation artifacts, and they have a relatively well-developed open source software community. So that kind of has helped smooth over some of the rough edges of kind of getting the robot to work well.
I see. Regarding the hardware you mentioned, do you think what's the kind of bottleneck of hardware, like the parameters or the battery, or do you see any limitations or current robotics?
Yeah, so the first, as I said, it is not a bottleneck yet, but I think it will be very helpful if we have lots of we have new sensor are doing this touch, then we can have more sensing data, be able to complete the data set we have. Another thing also, another challenge, bottleneck as mentioned, because I was a material scientist from Stanford. One of my research was focusing on is a battery, lithium-ion battery and multi-junction solar. Battery and energy definitely is another thing that has a bottleneck for robotics in order to run independently. Another thing I want to highlight is really the latency. For robotics to really solve the latency issue, we have to run AI on the edge devices. We've been investing in edge computing for a long time. We also are investing in company doing the smaller size, a smaller model could run on edge devices, which also means they could potentially consume much less energy and also computing consumption for running this AI model.
For the robotic, this big one, do they also have a battery saying people need to take it down? Yeah.
So now I've actually looked at most of like a decent number of different robots, and for the most part they're all actually fairly similar. The batteries that the high-end robots are using, let's say like Figure, is the battery that Figure is using is not really meaningfully better than a battery that you can put on your e-bike. So the motors that high-end motors are also I think not really meaningfully different from a motor in a hoverboard. So if you actually kind of break down the hardware for a humanoid robot, it's more or less commodity like stuff, and I think that as people start to sort of make them useful, there's going to be a lot of emphasis to make things cheaper and more commoditized. So yeah, like it is difficult. I think it's especially difficult in the United States because there's not a lot of that knowledge here on how to do things. So a big part of like what has helped me unblock our company on just making progress on the hardware side was getting to go to China and meet people that have been doing this kind of professionally. Kind of get a sense of the right way to do it. But yeah, really, I think on the hardware side, like humanoid robots are not a particularly difficult thing to build. It's more or less the same. Like, it's more or less, a humanoid robot is basically just a hoverboard with more motors.
Yeah.
And plus the inference chip and cameras and audio, but a lot of that stuff is essentially commodity. So on the hardware side, it's really not that difficult per se. It's difficult in the US just because it's difficult to find people that know how to do hardware stuff here. On the software side, it's a different story. On the software side, I don't think there's like no one's really solved it yet. I think it's like people have a pretty good idea that if you can get a large pre-trained multimodal model to run in real time on the edge in a robot, that will probably be meaningfully better than any of the existing sort of like small PPO policies or MPC approaches that Boston Dynamics has taken. So that's a big unsolved problem. A lot of people are betting on it, including us. I think it's not going to be something that you can solve just by training a better model. It's going to be like you have to really integrate with the hardware in the way that, like, you know, Tesla's got really good models now because Tesla's fairly well integrated with the hardware. But having worked on that, I know it's not easy. So anecdote is like when we put one of the sort of early transformer models into the hardware, we trained it, me and my friend Patrick trained it in 2 weeks, and then we spent 3 months getting it to run in real time. So yeah, the balance of engineering is actually probably more on the integration side is the difficult part, more so than actually training the model or any particular insight. Although getting the model to work well is still difficult. So
we know that we invest a lot of robotic companies. What's the kind of biggest challenge or risk you see when you do investment towards this kind of companies?
Yeah, I think robotics, number one thing is really just the people's expectation of the technology. For example, if it's a human labor make 1% mistake, you're actually okay with it. But when it comes to robotics and also the machine, the tolerance is much lower. 0.1% may not be really accepted by the general population if you're using robotics or doing certain type of services. So I think it's really important for initial robotics application, choose the right industry to focusing on. What is more generic to general population consumer side, I more narrow down to specific industry which have more reasonable expectation of the error rate and also the service quality. So that's number one thing. And the second thing more practically is really just always the cost of the technology. Lots of the sensor and also lots of the system integration being existed for a while. The challenge is really how to make first the hardware cost become cheaper. This cost related to the hardware sensor itself and also the cost of assembling things together, system integration. And another cost is also related to, when you're deploying this solution during the training, how much time and the data you need to input in order to train the robotics. The ideal case, now you also saw some interesting research from Stanford, is we hope robotics could watch the YouTube video, right? Watching how people do different tasks and be able to quickly learn from it instead of hundreds of thousands rounds of the training session in order for robotics to be more accurate. So I think that's another major challenge is really the general cost of technology related to the hardware and also the training. The last one is really the regulation. For now, it's still the safety and the regulation haven't been discussed enough yet. We've been talking about the safety and regulation of AI, but AI plus robotics probably has a more near-term requirement for discussion of the regulation. And we need a very clear guideline about where we could implement this type of robotics and also how to implement it and what is the potential procedure need to be put on top of it in order to make sure there are no compliance issue, especially for the sector I'm mentioning. We don't invest anything consumer related. We invest only industry application, AI robotics application for healthcare, for logistics manufacturing, for insurance industry, for space industry. All these industries are highly regulated industry. So even you're a new technology player, you still need to go with the existing guideline of the target customer. And I think the last is really the sensing data. We have lots of the data collected by robotics already. It's also a really amazing platform as the entrance of the data. That's the reason since 2 years ago, even last year when people are talking about generative AI, or like beside generative AI, robotics is having their momentum right now because we need more touch point as the extension of the human to collecting data and also become the entrance of the data. So we have computer vision, we have natural language processing, we don't have sensing data yet. We don't have enough sensor data yet. So we need to have better sensing sensors in order to have this touch to help us collecting more sensoring data to complete this data set collection for the robotics.
So from an investor point of view, for the robotics startups, do you see what stage are they currently? Like basic stage, that's just starting, or application stage, they already, or like business model kind of mature?
Yeah, I think this is not the first time robotics become a major trend, right? I actually have, we work with the organization called National Robotics Engineering Center based in Pittsburgh. You probably know them. They have really good, robotics innovation, initially from military application and then spin off some technology for commercial startups. So many years ago, it's 2017 or 2018, the spin off a company, the name called I Am Robotics. From the name, you can tell it's a robotics company for inventory management. A very good technology because the military level downgrade to the commercial application. So we were the seed round early stage investor. And a year or 2 years later, company was acquired by one of their customers. But they were pretty mature in application already. It's just that they didn't use a large language model at the time, but they're of course using the typical machine learning, right? Now I think the new trend is powered by the new large language model. It's much easier to train. As I mentioned, LLM also help with reasoning and also help with other different use cases to deploy. That's the reason now we're seeing another wave of a robotics company coming up. But I think the fundamental challenge is still kind of similar. As Ben mentioned, the software and hardware integration is always the case. I was in material science and now I invest in AI company for the past 9 years. Lots of the AI application, even if it's purely software, is also important for founder to understand. You're applying AI for this industry, which may have a relative outdated infrastructure. This hardware-software integration is important. The industry not necessarily need the most fancy AI solution because the most advanced AI solution not necessarily solve the problem. The cost of the tech, that's another concern, whether AI is affordable, ROI of the technology. Same thing come back to robotics. Now you have a better training model, you have a more diverse use cases, still come back to the challenge of the hardware software integration, the cost of the technology, integration process, and also eventually the ROI of this application for a certain industry. So I think for lots of companies we're talking to, there's excitement. We're working on the industry research report on robotics right now. We're seeing lots of new application use cases came out in the past 1 or 2 years. Many of them are between seed and Series A stage, and we're seeing some of them are making good revenue already. Revenue, I'm talking about a couple $1 million with early pilot program. And for the specific AI in healthcare sector, we are also seeing some nanorobots application are going through FDA approval process right now. So I think we're just getting started for this new, not a new tech, but a new trend of this existing technology. And hopefully in the next 3 or 5 years, we'll see more companies grow up.
It sounds very exciting.
Do you know Thomas' research environment right now for the robotics? Why to adapt to open environment?
So for me personally, I'm not very enthusiastic about any particular robotics vertical because having worked in AI for my whole career, I think it's very difficult to get AI models to do well on a single task. I think this was the lesson for a lot of people in the last couple of years with what AI startups have sort of gone on to be successful and which ones haven't. There was a lot of, I remember several years ago there was a lot of general consensus that companies trying to specialize around building a single AI model were doomed to fail because ultimately that model was going to be commoditized and the companies that could build moats in other aspects were going to be the ones that were long-term able to be successful. I remember hearing this about companies like Suno AI or Kscale Labs or Midjourney even. And sort of the fast forward a little bit, it's it turns out that it's actually incredibly difficult to build a good model, a model that solves a real world task. But if you can do that, it actually usually can solve a large number of real world tasks. So as an example case for robotics, let's say I want to build a grocery shelving robot. And I have some vertical integration with grocery stores. I can go make some partnerships with people that let me put robots in their store. I think people historically have had this kind of flavor idea in robotics. And the problem is it's actually extremely difficult to build that robot. But the thing is, if you can build a robot that works in a grocery store for shelving, 99% of the time, you could probably also use that robot for a large number of other things fairly easily. Once you've solved this very, very difficult technical problem. And so it doesn't really make sense to sort of stay a verticalized company. And in fact, I think it gets even deeper where the process of going and building this thing in the first place, you need to start with the assumption that you will be a general purpose platform if you want to really build a great AI model. The example is like, let's say you want to build an image generation model. It doesn't really make sense to build, a cat generator. It makes sense to build a thing that can generate any image and then ask it to generate cats, because that's the sort of flavor of thing that will, kind of do well. And I think the same lesson is going to apply with robotics. It's not a popular opinion. I think, I think there's a lot of investors that I've spoken to that have kind of said that it's better to verticalize, and you want to figure out a way to have that way you can work directly with your customers. It's just I haven't seen that be successful with any kind of AI modeling company. I think people just underestimate how hard it is to build a great model, a great experience, and sort of overestimate the value of having like a particular vertical that you're trying to build for. I should say this is specifically for kind of the new flavor of machine learning that has emerged. 5 years ago, it was the opposite was true, where it made sense to go choose a vertical and specialize for that. Like, if you're building, bounding boxes for cars, it made sense to go collect a lot of images of cars and sort of build a really good model for, drawing, bounding boxes around cars. It's just that that's not really the case anymore. The case is like now you want to build a model for everything that can run on, work well on everything that you could throw at it, and then ask that model to do something specific, the way that Midjourney is done.
I understand vertical is very difficult right now, but from the cost and ROI standpoint, from Lou and your standpoint, if we do it more general, is it more difficult to achieve the ROI, or maybe it will increase the cost? Or
yeah, exactly. I mean, I personally think that it is not like that's what we're trying to thread the needle on. Is like, can we buy? Like, first of all, we have the cost of hardware needs to come down a lot. Like, you can't build general purpose models for everything on a $100,000 robot. It has to come down to like somewhere close to 5K or lower. But in that world, which I think we're going to get to fairly soon, I think it just, like, pragmatically speaking, it just doesn't make any sense to build. I think it just doesn't make any sense to build a model for like a single vertical. And a good analogy is like, let's say you wanted to start a self-driving car company today. Would you go out and collect a bunch of self-driving car data and sort of like get watch a bunch of people, it would be very expensive to go and sort of do the repeat the way that people are trying to get self-driving cars to work 5 years ago. But what we have today is these models that are trained on all of the data on the entire internet, and next year, let's say Llama 4 comes out, we're suddenly going to have a much better model for just general video data. So the thing that I think if you were starting a self-driving car company today, you should figure out how to take a large pre-trained model that knows everything about the world already and use that to drive your car. I think the same thing is true for robots.
Got it. Lou, do you want to have some add-on?
Yeah, happy to quickly chime in here. So for us, from very practical perspective, as you ask about considered ROI of technology, we specifically looking for a vertical model instead of generic model. I think, yes, maybe one day we'll have one AGI be able to have a generic large model to answer all different type of questions across different industry. Even that happens, think about the token size. Think about how much GPU consumption, how much energy consumption to support that model. It might work very well, but it's going to be super, super expensive. For now, to be honest, most of model provider, not most of all the model provider and large tech company, asking them whether they're making money for the API call of their model. It's just so expensive right now. So for us to look at how to make it sustainable and for industry to be able to really think ROI makes sense, is about vertical model, vertical application. Because when you're building vertical model, you don't need to cover all the edge cases. You only need to train on top of all this high quality industry data, be able to cover all these edge cases for a certain industry. When you narrow down to specific industry, you'll find out, generic human behavior could be crazy, and we ask all lots of the random questions, but for certain industry, the high quality industry related domain and the data have pretty good structure already. So you don't need to cover so many edge cases within certain couple billion size billion token size model, you'll be able to make it highly professional and accurate. So the cost of AI implementation will be much lower and also will be more sustainable for industry customer to consider utilize it. We always think about when a consumer looking at AI solution, you always think about what is the best, the fastest, and also easy to integrate and engage, and the UI need to be very easy to understand. But when you come to the large corporate, number one thing to ask whether it's secure. I don't want to have any compliance issue. Second thing, cost. Whether cost is cheap enough for me to justify the cost reduction and productivity improvement of adding in this new solution. After that is better, faster. We can always talk about innovation need to be better, faster, cheaper. When you look at the needs and also requirement from the customer, you have to rearrange the priority. It has to be safe, cheaper, better, and faster.
Like some researchers suggest that creating a successful foundation model for robotics requires a large amount of real-world robotic data, right? How do you plan to tackle this problem with the things you try to create it?
Yeah, I mean, our answer is pretty much like get robots into people's hands that want to use them and sort of like as quickly and cheaply as we can. I think like where I was frustrated with most of the existing robot companies is that almost all of them are trying this kind of like go to a factory setting first and then you can bring the cost down for the robot and then finally go into the consumer or enthusiast hands. Like I don't know why it's so hard for someone like me to buy a robot, because I'm the best person. I want to make them better, So if you can find people like me, like can you get a robot into them, like to them as quickly as you can? Because if you can do that, then you can collect data. Because I know myself, I will work with anything. I will like actively try to make it better for free. Basically, you don't have to pay me to teleoperate your robot. You don't have to come up with some contrived scheme to pay for people to improve it. Like robots are cool.
How do you see the robotic data problem from the robotic creation landscape, and how does it impact the startup evaluation?
I think it's not only for robotics, for most of AI application right now, especially for industry application, access to data is the key differentiation. Yeah, you could call different API, you could build your own model, but I think used to be okay, we need to have huge amount of data to train the model. Nowadays, in order to further fine-tuning the model, make it even better performing, the quality of the data sometimes matters more than the quantity of the data. And also quality of the data is not only it doesn't have noisy data. It's also the diversity of the data, means how many edge cases you included in this data set. And in order to have access to the data, high quality data, that's a unique advantage that founder has to figure out a way to have. That's the reason I go back to what Ben mentioned about Tesla, right? Why they could train a model so easy, because they have tons of data, high quality data they've been collecting. Other car manufacturers, they have amazing hardware capability, but they don't have this data for training. So access to data is important. How does the smaller startup competing with large one? That's also a thing we're always think about how we could better serve the company. For some of the startup we work with, we do have a strong connection with the CTO of lots of Fortune 500. Then be able to identify and know which large corporate, they have lots of internal data they're willing to share with a small startup to form the partnership. I think this type of partnership is very important for smaller startup to get started. And also if founder have access, they should try to form the partnership earlier than later. Because once, for example, if I'm a large corporate, I've shared my data with one phone company already, another will come up, I even like that solution better, it's hard to migrate. So founders should consider this partnership earlier than later.
Thank you. What are the most interesting robots and AI innovation recently?
You mean AI plus robotics? So I think recently I saw two types, which also relate to the sector I've been focusing on. One is, of course, AI robotics for healthcare. I've been talking about concept of nano-robots for many years, since 2016, 2017. I think in the past 1 year, we're seeing lots of the real application for example, smart pill, like a small robots. And with AI implementation, you'll be able to take the pill to collect microbiome data from your GI system, which is not only beneficial for the diagnostic of typical GI diseases and different cancer. this type of biomarker, this is the first time ever we'll be able to collect it, could potentially be an important biomarker for mental disease diagnostic related to dementia, Alzheimer. So that's one area I found super interested. It's also now the typical robotics you're going to imagine, like larger size, lots of hardware. It's a more smaller scale, but bring the innovation to a different dimension. Another sector is really AI robotics for space industry. We're all super excited about the successful launch of Starship. Now the launching cost in the near future are going to be significant lower. Meanwhile, we also have lots of satellite already in the space and about to have much more in the near future. Of course, that's exciting, but meanwhile, there's lots of garbage and also the collision happening across the space. So using AI plus robotics to handle the traffic of the satellite, be able to potentially clean up the orbit for different satellites, that could be an interesting application in the near future as well. So I'm talking about something very small and something beyond the Earth, up in the space, but per your questions, may happen in the next couple of years, not too far away.
Yeah, I remember when I was young, right? I saw there was a novel talk about this like nano robotics, right? Once you put a pill into it, they will work on your body and try to fix something which originally need to make an operation.
That would take more than 10 years. I think now we're still in the original phase that we could have potential smaller scale robotics go inside a company, go inside a body as a monitoring and also kind of doing the touring of your internal system. But in order to actually fixing things and doing micro-invasive surgery, it will still take some time, but definitely that's the one direction.
That's great, right?
What do you think is the next breakthrough in robotics?
I think the thing that I'm most excited for is going to be like a single model, a single like pre-trained large multimodal model that is able to do both manipulation and locomotion. So the idea is that you can currently train, good locomotion policies with PPO. Unitree's done a great job. They had a really cool demo recently. And you can train some manipulation policies as well. Like you can train with, for tasks, specific tasks. I think like the thing that's really going to be the breakthrough is unifying those two together. I mean, there's starting to be a lot of work in that domain. And more importantly, taking a large pre-trained multimodal model and using that as the foundation for those two things. Like if you can kind of extract the information that's already exists in those large pre-trained models and sort of demonstrate generalization to both manipulation and locomotion, I think that's probably the most promising approach. I don't think I'm the only person that believes that, but yeah, it's a hard problem. I hope there's going to be some cool papers. I think it is kind of a data problem though. It's very hard to actually just train that type of model a priori, or like if I were to sit down today and try to train that model on whatever data sets that exist today, it'd be pretty hard. I don't think it would generalize well. Like RTX, Octo, those types of models don't tend to generalize that well. So it's going to be a slog. It's going to be like, the Tesla, 12.4 or 12.5 release. Yeah. I have some good friends that worked on that, and it's pretty hard.
What trends and innovation you can think of for the next 12 months?
Oh.
Which is a time lapse piece, but yeah.
Yeah, I mean, the most exciting thing for me is it seems like we're on the verge of having a really cheap humanoid robot. Even since we got started, when we got started in January, the cheapest robot you could buy was $90K, and today there is a $5K robot. Wow. And and I think it's just gonna the prices gonna keep going down. So we're really about to have a product that anyone can buy, or not anyone, but most people could afford in the US. I think there's going to be a lot of challenges with getting it to them. But that's the thing I'm most excited about, is it just feels like the same thing that happened with personal computers, where there was the thing that let Microsoft get started was the Altair 8800. And once the Altair 8800 was possible, you could go to your friend's house And if he was doing some tax thing, for example, you could write a program in BASIC on his Altair 8800, and suddenly he could do his taxes on his computer. And I think it'll be the same for humanoids, where there's going to be this point where when an average person can buy a humanoid, and I can go to my friend's house and just kind of program my friend's humanoid to do his laundry for him or do some task for him around the house, that's going to be the thing that really changes the world. So.
Sounds good.
Hi, Ben. Since you are kind of open source solution, you mentioned that you want to co-develop with a lot of fans of your hardwares. Could you share a little bit how you will do this part? How you can kind of co-develop with those people who love your robots?
Yeah, we have a Discord community that we communicate all of our technical ideas in the Discord community. Mm-hmm. We've had a lot of great people kind of that we've met through that. Ling Kong was one of them. Mm-hmm. I think we try to be pretty open. All of our stuff is on GitHub. We have people that submit PRs, and that's probably the best way if people want to get involved with our project.
How do you perceive the open source versus closed source for the robotics?
I think now is a really early stage of the development of AI and robotics, and we need more contributor to the open source community in general just to push the technology moving forward. I really like Ben's idea in terms of essentially my understanding is that you're creating something like a Raspberry Pi, very easy for people to plug in and also play with it. And more people start to contribute, more people start to create different use cases with the very easy to implement robotics platform within AI implementation. That's what we call the future of technology. The entry barrier could be much lower. So come back to your question regarding open source and also closed source. I think we already have enough large corporates doing their own model and their own product, and we need to have a different community in order to try to experiment a different possibility. And also diversity of the technology is also very important. That's another important contribution for the open source community. And when we see diversity, that's also the key part of innovation. That's the reason why as an early stage investor, I'm personally super bullish about open source. If you remember, we had conversation since early this year, or even last year, I've been talking about open source type of the company I'm investing, and also a founder, how they contribute to the open source community. Especially now we talk about, yes, you could do a large language model, but now for the real industry application could come down to the smaller size model, vertical model, and all this smaller size and vertical model could benefit from the open source community.
At the end of the podcast, let's talk about something regarding the entrepreneur.
Since you've been working on your startup for a while, if you can redo three things from beginning, what are they?
I probably would have visited China earlier. I had so many random technical issues when we were doing YC that all I had to do was go talk to someone in Shenzhen, and they could have told me the right way to do it. I spent probably 4 or 5 days of just sitting and soldering wires by myself. And you can buy these wire harnesses pre-assembled in Shenzhen, so it would have saved me a lot of time. That's the main thing. I think we probably would have gotten a place with 2 bedrooms so that Matt and I don't have to sleep on above each other, because it's very loud. We had a very creaky bed that it moved a lot, so it was hard to sleep sometimes.
Is there any particular reason you choose Silicon Valley to start your robotics startup?
If you want to build AI stuff and you want to be a serious AI company, you kind of have to be in Palo Alto, in my opinion. So there's just a lot of people. I should say I used to live in Palo Alto, when I was working at Tesla, and then my wife got her medical residency in New York, so we moved to New York. And just the experience of being in New York and trying to do cool AI stuff, it's very, very difficult to do things. It's just, you're not around people that are doing this stuff. You go out and everyone wants to go to parties or stuff, something like that. Palo Alto is so boring. No one wants to party. It's great. You can just work all the time.
You're saying it's that kind of environment kind of inspire you and try to push you moving forward.
Yeah, I mean, I think it's just one of the good things about Silicon Valley is like it was a good way to meet just people that I really admire and who I wanted to impress. It's also a big part of why we're open source too. Besides all of the, other stuff about building a developer community, I think the most important thing for me is to basically I think it's a huge privilege to have the opportunity to show people what exactly like I can do in some sense. And I wanted to set up a situation where like, if I do something bad, it's going to embarrass me a lot and it's going to make me feel bad and it's going to make me want to work harder. Cause that's good. That's how people like make good stuff. And I want to make good stuff before I die. So,
do you have something you feel like it's very inspiring you want to share with us here?
How to Win by Jen Gross. It's a really good YouTube video. Everyone should watch it. He talks about just general stuff like you need to go to sleep at night and eat healthy, exercise. But the last part is really good. He talks about kind of the different like psychological states that people should get to. And in particular, he talks about kind of like having the most important role, like a CEO or someone starting a company, is to quickly kind of develop an appreciation for what the people around you are thinking, like the dynamics of the like environment that you're existing in. Because it was very stressful for me early on to like kind of navigate like going from doing like in the weeds engineering problems to like kind of navigating all of the intricacies of raising money and talking to open source community and like hiring people. And the sooner that I could kind of get to a point where I like could kind of like start seeing what other people around me were thinking and develop a model for the world around me, the easier it made it to kind of deal with all of these different things. It's a great talk.
For those people who are doing AI startup or are going to do you have tips for them?
I think there's two types of AI startups that can succeed right now. There's startups that are building ChatGPT wrappers, you could call it, like essentially web apps or different types of apps that are powered by ChatGPT. And some of those startups are doing very, very well. And then I think there are startups that are focusing on building a model, a really good model for something. I think the area to avoid is like the startup where the only way to make it good is to build a good model and then try to get that to verticalize. Because I think it's really hard to build a model that no one else is building. Mm-hmm. And if you want to build a model that no one else is building, you have to only build that model. And that has to be like the main focus of the company. It's a good time to quit your job and start a startup too, because all the smart people haven't done it yet because they're getting paid too much money. So there's like a lack of smart, capable founders and more money than people know what to do with for those founders, is my experience.
Thank you so much for your time today.
Thank you.
Yes,
thanks for having me.
Yeah.
Very cool.